Here we're asked to graph a function's inverse. We're told given f of x is this graph below, graph f inverse. We'll do this by first graphing the line y equals x. This is because all functions and their inverses are reflections across this line. One point on that line is 0, 0. And then every other point where the y-coordinate equals the x-coordinate is also a point on that line. So at 4, 4, we have another point on the line y equals x. So we'll just connect the dots and make ourselves a nice line to reflect across. And this is the line y equals x. Every point that was on this side of the line will move to this side of the line. And every point that's on the line will stay on the line. This point looks like it's at about 0 and 1.5. So it will go to 1.5 and 0. That's this point right here. It's been reflected across to there. This point stays on the line, and this point stays on the line. We can kind of see part of this curve starting to develop. And you can see how this part is reflected across the line y equals x to this portion. Now we'll do the other points. This point is at 5, 0, so it'll go to 0, 5. And it looks like our curve kind of slopes back on itself into there. We can see that now this portion of the function has been reflected to that portion of its inverse. Now we'll do this point. It looks like it's at 7, negative 2, so it'll go to negative 2, and 7 is up here, so negative 2, 7. And the curve kind of went into it and then changed directions and came out, so we're going into it, and then we'll change direction and come out. And so that looks pretty good. It looks as though this whole branch has been reflected to represent this whole branch. Now we just have to do this linear looking portion. This is at the distance negative 2, positive 2, so it'll go to positive 2, negative 2. And it looks like it was connected with a straight line, so I'll use my ruler. And I've now graphed f inverse. It's really important to note that f itself was a function. If we place a vertical line all the way across f, we never get to 2 points that are connected by that same vertical line. The same is not true, however, for f inverse. If I draw a vertical line through the coordinate, or with the equation x equals 1, the vertical line will intersect the inverse at 3 points. Here, here, and here. So this is again proof that not all inverses are functions. So again, just to recap, we started by graphing the line y equals x. Then we plotted some of the points that were on the line. Then we reflected each point across that line and connected the dots, demonstrating a reflection in the line y equals x.